Today we will learn what are whole numbers and how to express them on the number line. In our daily life, we count in many situations. Counting the students in a class, counting the days, weeks, and months, counting various objects, etc. Whenever we begin counting, numbers like 1, 2, 3, 4, 5, 6, 7, 8, etc. come to our mind naturally. That's why we call them natural numbers. Natural numbers begin with 1. Therefore, 1 is the smallest natural number. Can you tell me what will be the largest natural number? Think about it. Counting never ends, which means natural numbers are infinite. For this reason, the largest natural number cannot be known. If 1 is added to a natural number, then we get the natural number which is next to it. This number is called its successor. For example, successor of 3 is 4 and successor of 4 is 5. But if 1 is subtracted from any natural number, then we get the natural number which comes before it, which is called its predecessor. For example, predecessor of 3 is 2 and predecessor of 2 is 1. Can you tell what will be the predecessor of 1? Think about it. Let's find out. Suppose there are 5 birds on a tree. Birds begin to fly away one by one in search of food, due to which the remaining birds are 4, then 3, then 2, and then 1. If this one bird also flies away, then how many birds will remain? None. It is expressed with number 0. Now you might have understood that 0 is also very useful for us, just like natural numbers. Therefore, we make a new collection or group of numbers by adding 0 to the list of natural numbers. This collection is called whole numbers. This way, we can now write the predecessor of 1 as 0. Number line is a suitable way to understand much about whole numbers. The number line is a straight line on which the numbers are placed at equal distances. The equal distance is called unit distance. Generally, the number line is represented horizontally. On the number line, the value of number increases from left to right. Similarly, the value of number decreases from right to left. With this understanding, numbers can be compared very easily on the number line. Draw a straight line to make the number line of whole numbers and mark points on it at equal intervals. By giving names such as 0, 1, 2, 3, etc. to the points, we can create the number line for the whole numbers. Today we have learned what are whole numbers and how to express them on the number line. In the next video, we will see some examples to understand it in a better way. Today, we will learn how to compare whole numbers and how to find their successor and predecessor. Write the successor and predecessor of following numbers. Successor of a number can be obtained by adding 1 to that number. Similarly, predecessor of a number can be obtained by subtracting 1 from that number. In this way, by adding 1 to 1350, we get its successor 1351, and by subtracting 1 from it, we get its predecessor 1349. Similarly, by adding 1 to 4,08,089, we get its successor 4,08,090, and by subtracting 1 from it, we get its predecessor 4,08,088. Next example. Write the appropriate symbol between the following pairs of numbers and also express in which direction is the first number with respect to the second number on the number line. Number 6 is smaller than number 12. So 6 is located on the left side of 12 on the number line. Number 70 is larger than 50. To express these on the number line, we have to keep a reasonable distance between points. Here, we will keep distance of 10 units between the digits. Therefore, numbers 70 and 50 can now be expressed on the number line. We can see that the number 70 is located on the right side of 50 on the number line. Next example. How many numbers are there between the following pairs of numbers? To know how many numbers are there between any two whole numbers, first, we have to subtract the smaller number from the larger number and then subtract 1 from the result. By doing so, we can say that there are two whole numbers between 2 and 5. Similarly, to find the whole numbers between 45 and 69, we will find the solution of 69 minus 45 minus 1. After finding the solution, we can say that there are 23 whole numbers between these two numbers. Now can you find out how many whole numbers are there between 352 and 689? In order to find it, we have to find the solution of 689 minus 352 minus 1. The solution is 336. This means that there are 336 whole numbers between these two numbers. From these examples today, we have learned how to compare whole numbers and how to find their successor and predecessor. In the next video, we will see some misconceptions about whole numbers. Today, we will learn some misconceptions related to whole numbers. Misconception 1. Which is the smallest natural number? When the concepts of natural numbers and whole numbers are not clear, often 0 is considered as the smallest natural number. This is a misunderstanding. The correct understanding is that natural number starts from 1, therefore the smallest natural number is 1. 0 is not a natural number. It is a whole number. Misconception 2. Which of the following statement is true? The collection of natural numbers along with 0 forms the collection of whole numbers. That means all natural numbers are whole numbers as well. Often there is a misunderstanding that all whole numbers are natural numbers. This is a misunderstanding because 0 is not a natural number. Misconception 3. How to find the number of whole numbers between any two whole numbers? Often there is a misunderstanding that by subtracting the smaller number from the larger number, the number of whole numbers between them can be found. To know the number of whole numbers between any two whole numbers, we must subtract smaller number from the larger number and then we have to subtract 1 from the result. So, option 2 is the correct answer. Now you must have understood whole numbers clearly by clarifying these misconceptions. In this video, today we will learn the operations of addition, subtraction, and multiplication of whole numbers on the number line. The number line of whole numbers starts at 0 and goes to infinity. Let us learn how the sum of whole numbers is represented on the number line. Look at this basket. There are 5 fruits in it. If we keep 2 more fruits with them, then how many fruits will be there? To find the value of this, we need to add 5 and 2. Let's express it on the number line. First number is 5. So we start with 5 on the number line. Since we have to add 2 to it, we will take 2 steps towards right from 5 to 6 and 6 to 7. To represent the steps, we will use arrows pointing towards the right direction. The last arrow points to 7. Thus, the sum of 5 and 2 gives 7, that is, 5 plus 2 is equal to 7. Now let us learn how subtraction of whole numbers is represented on the number line. Suppose we remove 2 fruits from 5. Then, how many fruits will be left? To find the value of this, we need to subtract 2 from 5. Let's express it on the number line. First number is 5, so we will start with 5 on the number line. Will you be able to tell in which direction we should go? Just think about it. Since we have to subtract number 2 from 5, we will take 2 steps to the left, from 5 to 4 and 4 to 3. To represent the steps, we will use arrows pointing towards the left direction. The last arrow points to 3. Thus, the subtraction of 2 from 5 gives 3. That is, 5 minus 2 is equal to 3. Now let us learn how multiplication of whole numbers is represented on the number line. Look at this basket. There are 5 fruits in it. If 2 more baskets containing the same number of fruits are kept with it, then how many fruits are there altogether? To find the value of this, we need to find 3 times 5. Let's express it on the number line. Like addition or subtraction, we will not start from 5. Instead, we will start from 0. Since 5 fruits have been repeated 3 times, starting from 0, we move 5 units at a time from 0 to 5, 5 to 10 and 10 to 15. To represent the steps, we will use arrows pointing towards right direction. The last arrow points to 15. Therefore, this is the product of the two numbers, that is, 3 multiplied by 5 is equal to 15. In this video, today we learned how to perform the operations of addition, subtraction and multiplication of whole numbers on the number line. In the next video, we will see some examples on this topic. Today we will see some examples related to the following mathematical operations of whole numbers on the number line: addition, subtraction, multiplication. There are 4 books on the table. If 5 more books are kept along with them, then what will be the total number of books? Find the solution on the number line. Here we have to add 4 with 5. First of all, draw a number line and mark the numbers 0 to 15 on it. You can express as many numbers as you want on the number line. The first number is 4, so you will locate 4 on the number line. Since we have to add 5 to it, we move 5 steps of unit distance each to the right of 4. To represent the steps, we will use arrows pointing towards right direction. Since the last arrow points to 9, therefore, the sum of 4 and 5 is 9. That is, there are 9 books on the table now. Example, Pawan had 7 pencils. He gave 4 pencils to Chanda. How many pencils does he have now? Find the solution on the number line. Initially, Pawan had 7 pencils, out of which he gave 4 pencils to Chanda. Number of remaining pencils can be obtained by subtracting 4 from 7. Let's express it on the number line. Draw a number line and mark more than 7 numbers on it. Since the first number is 7, we will locate 7 on the number line. The second number is 4. So starting from 7, let's move 4 steps of unit distance each towards left. Note that during subtraction, we move to the left, and during addition, we move to the right direction. After 4 steps, we arrive at number 3. This is the answer of 7 minus 4. Therefore, Pawan has 3 pencils left with him. Example, Mother gave 4 rupees each to her daughters, Ankita, Savita and Nisha. Can you tell how much money Mother gave to her children? Find the solution on the number line. In the example given, the total number of children is 3 and each one gets 4 rupees. Therefore, the total amount can be expressed as 3 multiplied by 4. Let's find the solution of the multiplication 3 multiplied by 4 on the number line. First, draw a number line. To represent multiplication on the number line, we always start with 0. The first number of multiplication tells us how many steps are to be taken, and the second number tells us how much distance to be kept for each step. Here, we have to take each step of 4 unit distance. Therefore, to express 3 multiplied by 4, we start with 0 and take 3 steps of 4 unit distance each towards right. So, after the last step, we reach 12. This is the product of 3 multiplied by 4. So, the total amount that the mother gave to her children is 12 rupees. In this video, we have seen examples of following mathematical operations of whole numbers on the number line. We will discuss few misconceptions related to them in the next video. Today we will see some common misconceptions related to the following mathematical operations of whole numbers on the number line: addition, subtraction, multiplication. Misconception 1. In what way 1 plus 4 is represented on the number line? While representing the addition of whole numbers on the number line, counting often starts from 0. This is a misunderstanding. With this understanding, incorrect answer option 1 is chosen. Similarly, the sum of 1 and 4 is represented by drawing arrows between 1 and 4 is also a misunderstanding. To show addition of 1 and 4 on number line in a correct way, we have to start with first number, then take 4 steps of unit distance each towards right. By doing so, we reach at number 5. With this understanding, option 3 is the right answer. Misconception 2. In what way 6 minus 4 is represented on number line? While representing the subtraction of whole numbers on the number line, sometimes arrows are shown from 6 to 5 and 5 to 4. With this incorrect understanding, incorrect answer option 1 is chosen. Similarly, subtraction of 6 and 4 is often represented by a single arrow from 6 to 4. This is also an incorrect understanding. The right way to find the value of 6 minus 4 is to start from 6, then move towards left by taking 4 steps of unit distance each. After taking 4 steps, we reach at number 2. This is the answer of 6 minus 4. Misconception 3. In what way 3 multiplied by 2 is represented on the number line? While representing the multiplication of whole numbers on the number line, counting is often done from the first number 3 and 2 steps are taken towards right with unit distance each. This is a misunderstanding. To multiply two numbers on the number line, one should start with 0. The first number of multiplication tells us how many steps are to be taken and the second number tells us how much distance to be kept for each step. So starting from 0, one has to take 3 steps of 2 units each. Therefore, the correct answer is option 2. Sometimes, instead of taking 3 steps of 2 units each, students take 2 steps of 3 units each. Although it gives correct answer, but this is incorrect way of thinking as it represents 2 multiplied by 3. However, we have to represent 3 multiplied by 2. So, option 3 is also an incorrect answer. Today we have seen the common misconceptions related to the following mathematical operations of whole numbers on the number line. In this video, we shall learn closure property with reference to the following mathematical operations of whole numbers. We already know that all the numbers from 0 to infinity are called whole numbers. If you are asked to take any two whole numbers from a collection of whole numbers and add them, will the result be a whole number? Think about it. Yes, we can say that the sum of any two whole numbers, AB, is always a whole number. That is, the collection of whole numbers is closed under addition. Instead of addition, if we subtract any two whole numbers, will the result be a whole number? Think about it. If we subtract larger whole number 3 from a smaller whole number 1, then definitely we get a whole number 2. Therefore, if A is a larger number than B, then A minus B will be a whole number. But if we subtract a larger whole number 3 from a smaller whole number 1, the same is not possible. Therefore, if A is a larger number than B, then B minus A cannot be a whole number. That is, when we subtract any two whole numbers from a collection of whole numbers, the result is not always a whole number. Therefore, the collection of whole numbers is not closed under subtraction. The multiplication of two whole numbers is found to be a whole number. That is, the multiplication of any two whole numbers is always a whole number. Hence, we can say that the collection of whole numbers is closed under multiplication. Similarly, if we talk about division of two whole numbers, then we get a whole number only when the number is divisible. But sometimes the result of division is not a whole number. For instance, if we divide 2 chapatis into 4 parts, then each part will get half chapati. That is, the result of 2 divided by 4 will be 0.5. The number of 0.5 is not a part of the collection of whole numbers, so it is not a whole number. Hence, the result of division of any two whole numbers is not always a whole number. So, the collection of whole numbers is not closed under division. So today we learned that the collection of whole numbers is closed under addition and multiplication. However, whole numbers are not closed under subtraction and division. In the next video, we shall understand this concept better with the help of few examples. Today in this video, we will see some examples of the closure property of whole numbers. Vipul and Meena are playing a game. Vipul is the first one to choose any two whole numbers and multiply them. Then, Meena picks two whole numbers and multiplies them. Whenever one gets a whole number as a result of multiplication, they gain 1 point. If the first turn is Vipul's, can you tell us whose points will be more at the end of the fifth turn? Since whole numbers are closed under multiplication, that is, for any two whole numbers a and b, a multiplied by b will always be a whole number. Therefore, Vipul and Meena can pick any two whole numbers and each time they will get a whole number. Like here, Vipul picked the numbers 2 and 3 in the first round and the result of his multiplication was 6. Hence, Vipul's score increased by 1. Similarly, Meena picked the numbers 3 and 4 and after multiplying them, she got 12, which is a whole number too. Therefore, Meena will also get 1 point. Now comes Vipul's turn. Vipul picked the numbers 5 and 2. Will he get 1 point this time? Think about it. You are right. The result of multiplication of 5 and 2 is 10, which is a whole number. So he will get 1 point again. After this, Meena picked two numbers 2 and 1, and multiplying them gave her the result 2, which is a whole number. So, she will get 1 point again. Now, fifth turn is Vipul's. Vipul picked the numbers 0 and 2. Will he get 1 point? Think for a while. Yes, you are right. 0 multiplied by 2 is equal to 0. And since 0 is also a whole number, Vipul will get 1 point. With this, Vipul scored 3 points and Meena scored 2 points. Thus, Vipul got the highest points. Next example. Explain the fact whole number is closed under addition. Let's take 3 examples for this. In these given examples, we added two whole numbers and the result was also a whole number. Similarly, if we take any two whole numbers a and b and add them, their sum a plus b will always be a whole number. Therefore, the collection of whole numbers is closed under addition. Next example. Whole numbers 5 and 0 are not closed under division. Verify this statement. Division means to distribute evenly. If you have 0 chocolates, which you have to distribute equally among your 5 friends, then you will not be able to give any chocolates to your friends. That is, the division of 0 by 5 will result in a whole number 0. Will the result of 5 divided by 0 also be a whole number? Think for a while. If you have 5 chocolates, which you have to distribute equally among your 0 friends, then you will never be able to share them. That is, you will never get the result of division of 5 by 0. Therefore, 5 divided by 0 is not defined. That is, the result of 5 divided by 0 cannot be called a whole number. Therefore, whole numbers 5 and 0 are not closed under division. In this video, we have seen examples of closure property of whole numbers. In the next video, we will see some misconceptions related to it. Today in this video, we will see some misconceptions related to closure property of whole numbers. Misconception 1. A teacher asked a question to the class. The question was, are whole numbers 7 and 4 closed under subtraction? To this, Mukesh replied yes and Rahul replied no. Can you tell me who gave the correct answer? 7 minus 4 is equal to 3. With the same understanding, it is assumed that 4 minus 7 is equal to 3. Since 3 is a whole number just like 7 and 4, 7 and 4 are considered to be closed under subtraction. So based on this understanding, Mukesh's answer seems correct. But this is the wrong answer. The correct understanding is that the result of 7 minus 4 is equal to 3, but the result of 4 minus 7 is not equal to 3. The result is minus 3, which is not a whole number. Instead, it is a negative number. Hence, whole numbers 7 and 4 are not closed under subtraction. With this, Rahul's answer is correct. We will learn more about negative numbers in the next chapter. Misconception 2. A teacher asked a question to the class. The question was, whether 6 divided by 0 is closed under division? To this, Nisha's answer was yes and Manisha's answer was no. Can you tell me who gave the correct answer? Sometimes it is a misconception that any whole number, when divided by 0, results in 0. Since 0 is also a whole number, Nisha gave the answer yes. Due to this misconception, option 1 was chosen as the correct answer. The correct understanding is that division of 6 or any other whole number by 0 is not defined. Hence, option 2 is the correct answer. In today's video, we saw some misconceptions related to the closure properties of whole numbers.
Today we will learn commutative property of the following mathematical operations with respect to whole numbers. We know that all the numbers from 0 to infinity are called whole numbers. Commutative property allows a mathematical operation to be solved by changing the order of the numbers. Let's understand in detail. Let's talk about the addition of numbers. Can we add two whole numbers in any order? Think about it. Let's suppose we draw 3 circles on the left and 4 circles on the right on a piece of paper. On doing so, the total number of circles we get are 3 plus 4 is equal to 7. If we rotate the paper this way, then the order of the circles will change. By doing so, there will be 4 circles on the left side and 3 circles on the right. Is there any change in the total number of circles? No. The number of circles is the same as before, that is 7. Thus, the commutative property of addition tells us that there will be no change in the final number even if we change the order of the numbers, which means A plus B is equal to B plus A. So, whenever you wish to find the sum of two whole numbers, you can add them in any order. You will get the same result even on changing the order of the numbers. Just like addition, is the subtraction of whole numbers also commutative? Think for a while. Let's see. Is it possible to subtract a smaller whole number from a bigger whole number? However, we cannot subtract a bigger whole number from a smaller whole number. Therefore, the subtraction of any two whole numbers A and B cannot be done by changing the order of the numbers. That is, A minus B is not equal to B minus A. Therefore, subtraction is not commutative for whole numbers. Now, let's talk about multiplication. If we make two rows of 3 balls each, then the total number of balls can be obtained by multiplying 2 and 3. The product is 6. However, if we change the order by making 3 rows of 2 balls each, then do we get the total number of balls same as before? Yes, 3 times 2 is also 6. This shows that multiplying two whole numbers in any order will result in the same product. Therefore, for any two whole numbers A and B, the product of A and B is equal to the product of B and A. Thus, we can say that the multiplication of whole numbers is commutative. Coming to division operation. The division of any two whole numbers A and B cannot be done by changing the order because A divided by B is not equal to B divided by A. For example, 4 divided by 2 is equal to 2. However, 2 divided by 4 is equal to half. Therefore, 4 divided by 2 cannot be written as 2 divided by 4 by changing the order. Therefore, division of whole numbers is not commutative. Today we learned that addition and multiplication of whole numbers are commutative, whereas subtraction and division of whole numbers are not commutative. In the next video, we shall deal with a few examples related to this property. Today we will see a few examples of commutative property of addition and multiplication of whole numbers. Rajesh keeps 3 apples in a basket, and after some time he keeps 2 oranges in the same basket. If Rajesh keeps 2 oranges in the basket first and 3 apples later, does that change the total number of fruits? Can we apply commutative property here? Case 1. Keeping 3 apples first and then 2 oranges in the basket. Total number of fruits equal to number of apples plus number of oranges, which is 3 plus 2, that is 5. Case 2. Keeping 2 oranges first and later 3 apples in the basket. Total number of fruits equal to number of oranges plus number of apples, which is 2 plus 3, that is 5. In both cases, there will be 5 fruits in the basket, which states that 3 plus 2 equal to 2 plus 3, or in other words, number of apples plus number of oranges equal to number of oranges plus number of apples. This example shows the commutative property of addition of whole numbers. Next example. There are 2 cupboards. There are 5 rows in first cupboard and in each row only 3 cups can be arranged. In the second cupboard, there are 3 rows and in each row only 5 cups can be arranged. Can you tell which cupboard will have the maximum number of cups? In the first cupboard, there are 5 rows and in each row only 3 cups can be arranged. So here you can arrange a total of 5 into 3 cups. Now, think about the second cupboard. Here the arrangement is a bit different. Here, there are 3 rows in which 5 cups can be arranged in each row. So, a total of 3 into 5 cups can be arranged in the second cupboard. Since multiplication of whole numbers is commutative, either we do 3 into 5 or 5 into 3. The answer will be 15. This shows that 15 cups can be arranged in both the cupboards. Next example. Fill in the blanks. Since addition of whole numbers is commutative, we will write 2 in the blank. Since multiplication of whole numbers is also commutative, we will write 7 in the blank. Today we saw a few examples based on commutative property of addition and multiplication of whole numbers. In the next video, we will see few misconceptions related to this property. Today we will see misconceptions and common mistakes related to commutative property of addition, subtraction, multiplication and division of whole numbers. Misconception 1. Teacher asked a question in the class. Is the subtraction of 77 and 33 commutative? Sarah answered, yes, while Roshan said no as an answer. Who gave the right answer? 77 minus 33 is equal to 44. Students also start thinking that 33 minus 77 is also equal to 44. With this misconception, students think that the subtraction of whole numbers is also commutative. With the same understanding, students think Sarah's reply is the correct answer and they choose option 1 as the right answer. This is an incorrect answer. The correct understanding is that 77 minus 33 is equal to 44. However, 33 minus 77 is not equal to 44. In fact, the result is a negative number, minus 44. We will learn about the negative numbers in the upcoming chapter. Since the result of 77 minus 33 is not equal to 33 minus 77, the subtraction of 77 and 33 is not commutative. With this understanding, Roshan has given the correct answer. Misconception 2. Is 6 divided by 3 equal to 3 divided by 6? It is a common misunderstanding that, just like addition and multiplication, division is also commutative. With this misunderstanding, incorrect answer yes is chosen. To find the correct answer, we must compare the results of 6 divided by 3 and 3 divided by 6. Let's find the result of 6 divided by 3. Suppose you have 6 lemons. If you wish to make 3 equal parts, then each part will consist of 2 lemons. So, the result of 6 divided by 3 will be 2. Now let's find the result of 3 divided by 6. If you have 3 lemons and if you wish to divide them into 6 equal parts, then how can you do this? Think for a while. You must cut each lemon in half to make 6 equal parts. Since each part has half lemon, therefore, the result of 3 divided by 6 is half, that is 0.5. Now if we compare the results of the two, then it can be understood that the values of 6 divided by 3 and 3 divided by 6 are not equal. Now let's understand some of the common mistakes related to commutative property. Often students know the commutative property, however they don't use it for simplifying the addition or multiplication. For example, the addition of 3 and 9 is done in the given order, whereas it is difficult to add a larger number to a smaller number. However, by changing the order, the result of addition can be obtained very easily. Similarly, multiplication of two numbers like 3 and 9 is also done in the given order, which appears difficult. But if we change the order, then the same multiplication turns out to be simple. Therefore, it is very important to have a better understanding of the commutative property. Today we saw misconceptions and common mistakes related to commutative property of addition, subtraction, multiplication and division of whole numbers.
Today, we will learn about associative property of the following mathematical operations with respect to whole numbers. We have read that numbers from 0 to infinity are called whole numbers. Associative property helps us to solve the mathematical operations by grouping the numbers. Let's understand it in detail. Let's talk about the associative property of whole numbers under addition. Let us suppose there are 5 beans, 3 beans, and 2 beans. If we want to find out the total number of beans, then which method will we use? We first find their sum, that is, we have to add them. One way to add them is to first make a group of 5 and 3 and add 2 to their sum. Or first, we will make a group of 3 and 2 and then add 5 to the resultant sum. No matter how we group the numbers, the result of addition will be the same. In this way, any 3 whole numbers A, B, and C can be added by forming a group of any type. The result of A plus B plus C is equal to A plus B plus C. This will always be the same. Therefore, whole numbers are associative under addition. Now let's understand the associative property of whole numbers under subtraction. Like addition, is subtraction of whole numbers also associative? Think for a while. If we group the numbers in this way, then first we will subtract 3 from 5 and then we will subtract 2 from the result. Therefore, the answer will be 0. However, if we group the numbers in this way, then the answer will be 4. The results in both cases are different. Note, only in this case, subtracting any 3 whole numbers A, B, C by making different groups result in different results. This means A minus B minus C and A minus B minus C are not equal. That is why whole numbers are not associative under subtraction. Now let's talk about multiplication. Look at this picture. Will you be able to tell the number of tablets by operation of multiplication? There are 2 tablets in each row. Therefore, 3 rows will have 2 multiplied by 3 tablets. And since there are 4 packets, the total number of tablets is 2 multiplied by 3 multiplied by 4. To solve this, a group of 2 and 3 can be made, or a group of 3 and 4 can be made. In both cases, the result is 24 tablets only. In this way, any 3 whole numbers A, B, and C can be multiplied by grouping in any order. The result of A into B into C is equal to A into B into C will be the same. Therefore, whole numbers are associative under multiplication. Now, if we talk about division, then any 3 whole numbers cannot be divided by changing the order of division. That is, for whole numbers A, B, and C, A divided by B divided by C and A divided by B divided by C are not equal. In this way, whole numbers are not associative under division. Today, we have learnt addition and multiplication of whole numbers are associative, but subtraction and division of whole numbers are not associative. In the next video, we will see some examples related to this topic. Today, we will see examples of associative property of whole numbers for the following mathematical operations. During one Mahotsav, Akash planted 9 trees, Ajay planted 7 trees, and Babita planted 3 trees. Can you tell how many trees were planted by the 3 of them together? To find the total number of trees planted by Akash, Ajay, and Babita, we need to add 9, 7, and 3. This can be solved by making a group of 9 and 7, the result being 19. Since whole numbers are associative under addition, we can also solve this by making a group of 7 and 3. The result of this will also be 9 plus open brackets 7 plus 3 close brackets, which is equal to 19. Can you tell which of the given methods is easier? Think for a while. As you can see here, that compared to 9 plus 7 in brackets plus 3, it is easier to solve 9 plus 7 plus 3 in brackets. In this way, associative property makes addition of whole numbers easy. In both the methods, the total number of trees planted by Akash, Ajay and Babita will be 19. Next example. To find the multiplication of 17, 25 and 4, how will you use the associative property? If we observe the numbers carefully, we can say that 25 and 4 can be multiplied very easily. Therefore, under the associative property, we can group the numbers like this: 17 multiplied by 25 multiplied by 4 in brackets. It will be easier to solve by making groups like this. Here, the product of 25 and 4 will be 100 and 17 multiplied by 100 equals 1700. Next example. Find the value of 50 multiplied by 669 multiplied by 20. It might be difficult to solve 50 multiplied by 669 multiplied by 20. However, by using the commutative property and associative property, it can be solved easily. Let's understand this. Using commutative property of multiplication, numbers can be written like this by changing their order, and using associative property, they can be made into a group like this. The product of 50 and 20 can easily be obtained as 1000. Similarly, the product of 1000 and 669 can be easily obtained to be 6,69,000. Today, we have seen examples of associative property of whole numbers for the following mathematical operations. In the next video, we will learn some misconceptions related to associative property of whole numbers. Today, we will see misconceptions related to associative property of whole numbers for the following operations. Misconception 1. Which of the following statements is correct with respect to associative property? We already know that whole numbers are associative under addition and multiplication. Due to difficulty in understanding, associative property is used in an incorrect way, and 8 plus 4 into 2 is assumed to be equal to 8 plus 4 into 2. With this understanding, option 1 is chosen as the answer, which is incorrect. Due to lack of proper understanding of associative property, option 2 is chosen. Whole numbers are not associative under division. However, many times, in order to make the operation of division easy, this property is used. With this incorrect understanding, option 3 is chosen as the answer. With the correct understanding of associative property, option 4 is chosen, which is the correct answer. Misconception 2. In a school, there are a total of 9 classrooms, and in each classroom there are 25 benches. If 2 students are seated on each bench, then find the total number of students in the school. Ramesh solved this question as 9 into 25 in brackets into 2, and Gagan solved this question as 9 into 25 into 2 in brackets. Can you tell who obtained the result easily among both of them? In general, associative property is considered meaningless and is neglected. Due to this, multiplication is solved only in the given order. The given example seems difficult to solve like this: 9 into 25 in brackets into 2, because first we have to multiply 9 into 25 and then we have to multiply the result 225 with 2. Whether it is the product of 9 into 25 or 225 into 2, both are difficult to find. But this can be solved very easily with the help of associative property of multiplication. This means one can find the product of 25 into 2 very easily. The result obtained will be 50. Then we will multiply 9 and 50, which gives the result 450 that can be easily obtained. Therefore, Gagan must have found the result easily and not Ramesh. Today, we have seen misconceptions related to associative property of whole numbers for the following operations. Today, we will learn about distributive property of multiplication over addition and subtraction of whole numbers. Suppose your father gives you 3 rupees and your mother gives you 2 rupees every day and you collect them in a piggy bank. Can you find out how much money you would have saved in 5 days? There are 2 ways to solve this. Method 1. Calculate the total amount saved in a day, which is 3 plus 2 rupees. So in 5 days, you will be able to save 5 into 3 plus 2 rupees. The solution to this is 5 into 5, which is equal to 25. Method 2. The other method is first you will find out the total amount given by your father in 5 days and the total amount given by your mother in 5 days. Now add these two values. That is, find the value of 5 into 3 plus 5 into 2. The solution is 15 plus 10, which is 25. Isn't this equal to the first solution? Yes. So can we say that 5 into 3 plus 2 is equal to 5 into 3 plus 5 into 2? What did you understand from this? Here, the sum of two numbers is split. That means multiplication is distributed over addition. Therefore, for any 3 whole numbers a, b and c, a into b plus c can be distributed as a into b plus a into c. This is called the distributive property of multiplication over addition. Can multiplication also be distributed over subtraction? Think for a while. Let's understand this. Suppose your father gives you 3 rupees every day and you spend 2 rupees of it every day. Then, what is the amount you would save in 5 days? We can solve this also in 2 ways. The first method, 5 into 3 minus 2, gives you 5 as the answer. And the second method, 5 into 3 minus 5 into 2, also gives 15 minus 10, that is 5 is the answer. Here, 5 into 3 minus 2 is equal to 5 into 3 minus 5 into 2. Therefore, multiplication can also be distributed over subtraction. This shows that for any 3 whole numbers a, b and c, a into b minus c can be distributed as a into b minus a into c. This is called the distributive property of multiplication over subtraction. Today, we have learned about distributive property of multiplication over addition and subtraction of whole numbers. In the next video, we will see some examples of this property. Today, we will see examples of distributive property of multiplication over addition and subtraction of whole numbers. 1 litre milk costing 35 rupees and 1 packet of biscuit costing 15 rupees are bought every day at Sachin's house. Can you find out the expense on these items in 7 days? Method 1. To solve this, we will find the total expenditure of 1 day, that is, the cost of 1 litre of milk plus the cost of 1 packet of biscuits, 35 plus 15. Now, how do we find the expenditure for 7 days? Think for a while. we have to multiply the total expenditure of one day, that is 35 plus 15, by 7. 7 into 35 plus 15. After simplification, we get 7 into 50, which is equal to 350 rupees. Method 2. First, we will find the amount spent on milk in 7 days, which will be 7 into 35. Similarly, we will find the amount spent on the packet of biscuits in 7 days, which will be 7 into 15. Then we will add them and get the total expenditure. Total expenditure is equal to 7 into 35 plus 7 into 15, which is equal to 245 plus 105, which is equal to 350. Thus, the total expenditure obtained by both methods are the same. In this way, 7 into 35 plus 15 is equal to 7 into 35 plus 7 into 15. This is the distributive property of multiplication over addition. The next example. The daily income of Harish's father is 315 rupees. Can you find out his annual income? In this example, it is given that Harish's father's daily income is 315. We have to find out what his annual income is. We know that there are 365 days in a year. Hence, his annual income will be 315 into 365. Finding the product of these two values seems difficult. But when we apply the distributive property of multiplication over addition, we can solve it easily. That is, 315 into 365 can be written as 315 into 300 plus 60 plus 5. Here, how do we apply the distributive property of multiplication over addition? Think for a while. By distributivity of multiplication over addition, we can write it as follows. Solving this, we get the annual income as 1,14,975 rupees. Next example. Find the value of 5 into 78 using the distributive property. We can write 5 into 78 as 5 into 80 minus 2. This can be written as 5 into 80 minus 5 into 2 by the distributive property of multiplication over subtraction. Solving this, we get 400 minus 10, which is equal to 390. Therefore, by using the distributive property, we can find the solutions very easily. Today, we have seen examples of distributive property of multiplication over addition and subtraction of whole numbers. In the next video, we will highlight some of the misconceptions related to this. Today, we will see some misconceptions related to distributive property of multiplication of whole numbers. Misconception 1. Which of the following expansion is correct for 2 into 188? Sometimes, distribution is understood as separating the digits, and option 1, which is an incorrect answer, is chosen. Similarly, instead of adding the digits, they are multiplied, and option 2, which is also an incorrect answer, is chosen. With the correct understanding, option 3 is chosen, which is the correct answer. Sometimes, the usage of brackets is considered unnecessary and they are ignored, and the given numbers are expressed as in option 4. This is also an incorrect answer. Misconception 2. How can we distribute 12 into 5 plus 7? While using distributive property, we need to multiply the numbers inside the brackets with the number outside the brackets. With this understanding, option 2 is chosen, which is the correct answer. Due to confusion in understanding the distributive property, sometimes the number outside the brackets is simply multiplied with the numbers inside the bracket. This is an incorrect way. Similarly, while distributing multiplication over addition, plus sign is written between the numbers inside the bracket, and the multiplication sign is written outside the brackets. This is also incorrect. Misconception 3. Which of the following expression is equal to 102 into 18 plus 102 into 32? While taking 102 as a common term from 102 into 18 plus 102 into 32, 102 in the first bracket is added to 102 in the second bracket. Therefore, option 1 is incorrect. The correct understanding is that the common number is written outside the brackets and the number which we multiplied it to are added and written inside the brackets. With this understanding, option 2 is the correct answer. Some important points related to distributive property. Sometimes there will be no correct understanding of distributive property, or sometimes it is just considered as a rule. Because of this reason, it is not applied to simplify the multiplication. In our daily life, we come across many situations where we can use the distributive property to multiply two numbers without manually multiplying the numbers on paper. That is why this is an important property. Today, we have seen some misconceptions related to distributive property of multiplication of whole numbers.
Today we will learn about the additive identity and multiplicative identity of whole numbers. You might have done counting several times in your life. Counting the students in a class, counting various objects, counting the birds on a tree, etc. Whenever we start counting numbers like 1, 2, 3, 4, etc. come to our mind naturally. That's why we call counting numbers as natural numbers. We use numbers like 1, 2, 3, and so on for counting. What if there is nothing to count? For example, if there are no students in the class, there is no one to count. What if all birds fly away from the tree? How do you express it in maths? Yes, you are right. Such number is expressed as 0 in mathematics. Therefore, if we add 0 to the natural numbers, we get the collection of whole numbers. 0 has a special role in addition. If any number is added to 0, that means if 5 students enter an empty class, or if we put 4 laddus in an empty plate, then the result will be the same whole number which is added to 0. Because of this reason, 0 is called an identity for the addition of whole numbers. 0 is the additive identity, or even called an identity element, or simply identity. We can see something similar in multiplication too. If any whole number is multiplied by 1, that means if there are 5 squares in a row, then the total number of squares is obtained by multiplying 1 and 5, which is 5. There are 4 baskets. If 1 fruit is kept in each basket, then the number of fruits will be 1 multiplied by 4, which is 4. Similarly, if the cost of each chocolate is rupee 1, then the cost of 15 chocolates will be 15 rupees. Why? Because 1 multiplied by 15 is equal to 15. Since any number multiplied by 1 gives the same whole number, is called an identity for multiplication of whole numbers. 1 is the multiplicative identity, or even called an identity element, or simply identity. Today we have learned about additive identity and multiplicative identity of whole numbers. In the next video, we will see some examples to understand this in a better way. Today we will see the examples of additive identity and multiplicative identity. If a bucket has 15 liters of water and another bucket is empty, then what is the total amount of water in both the buckets? In the given example, the first bucket has 15 liters of water. The second bucket is empty, which means that it has 0 liters of water in it. To find the total amount of water in both buckets, we have to add both values, that is, the value of 15 liters plus 0 liters has to be found. 0 is the additive identity. Can you tell me the reason? Let me explain. This is because if any number is added to 0, the result will be the same number. Therefore, the total amount of water is 15 liters. Next example. Poonam writes one poem every day. How many poems will she write in 30 days? Poonam writes one poem every day. Therefore, in 30 days, she will write 30 times one poem. 1 is the multiplicative identity. Can you tell me why? Let me explain. This is because if any number is multiplied by 1, the result will be the same number. Therefore, 30 times 1 is 30, which means Poonam can write 30 poems in 30 days. Next example. Find the value of 130 multiplied by 1 plus 120 plus 0. To solve this, we definitely need to understand the multiplicative identity and the additive identity. Multiplying the number 130 by 1 gives the same whole number, that is 130. Similarly, when 120 is added to 0, we will get the same number. 130 plus 120 is equal to 250. That is, the solution of a given example is 250. Such examples can be solved easily by understanding the multiplicative identity and the additive identity. Next example. How to express the following arrangements in multiplication. Here we have some rows of squares. To express this in multiplication, we write the number of rows first and then the number of squares in each row. Here, the number of rows are 6 and each row has 1 square. So, we will express this in multiplication as 6 multiplied by 1. As discussed earlier, by using the commutative property of multiplication, we can write 6 multiplied by 1 as 1 multiplied by 6 as well. But in practice, it will be expressed by making 6 squares in one row. Here, 1 is the multiplicative identity. So, whether we write 6 multiplied by 1 or 1 multiplied by 6, the result will be 6. Today we saw the examples of additive identity and multiplicative identity. In the next video, we will discuss some misconceptions related to this. Today we'll see some misconceptions related to additive identity and multiplicative identity. Misconception 1. Which of the following statement is true with respect to additive identity? If you add 1 to any number, then the number remains the same. It is a misunderstanding. When 1 is added to a number, its value increases. Therefore, option 1 is an incorrect answer. If you multiply any number by 1, then the number remains the same. This statement explains the multiplicative identity. Therefore, option 2 is not the correct answer for the given question. Sometimes option 3, which is, if you multiply any number by 0, then the result will be 0 is considered as correct answer with respect to additive identity. But this is also a misunderstanding. Option 4 is the correct answer with respect to additive identity. That is, if you add 0 to any number, then the number remains the same. Whether we add any number to 0 or 0 is added to that number, the result always remains the same. For example, 5 plus 0 is equal to 5. 0 plus 3 is equal to 3. Misconception 2. Choose the correct property among the following for the given example. 1 multiplied by 53 is equal to 53. Due to lack of proper understanding of multiplicative identity, option 1 and option 2 are chosen as the answers, but they are incorrect. Getting confused between additive identity and multiplicative identity, option 3 is given as an answer. This is incorrect. The correct way of understanding is when a number is multiplied by 1, the result will be the same number. This is the identity for multiplication, also called as multiplicative identity. Therefore, option 4 is the correct answer. Misconception 3. For example, 15 plus 0 is equal to 15. 0 is additive identity. Will 0 be additive identity for 15 minus 0 is equal to 15? By adding 0 to 15, the result is the same number, 15. Therefore, 0 is called the additive identity. Now, consider the example 15 minus 0 is equal to 15. When 0 is subtracted from 15, the result is the same number. Therefore, in 15 minus 0 is equal to 15 also, 0 is considered as additive identity. With this understanding, option 1 is chosen as an answer which is incorrect. The correct way of understanding inadditive identity is related to the addition of any number with 0. It is not related to subtraction, therefore the correct answer is option 2, which is no. Today we saw the misconceptions related to additive identity and multiplicative identity. Today we will learn about some interesting patterns in whole numbers. Numbers can have interesting patterns. For example, here is a pattern of the whole numbers. It is nothing but an arrangement of dots as triangles. Number of dots which can be arranged as triangles are called triangular numbers. A flock of birds sometimes take the shape of a triangle. Similarly, a fleet of aeroplanes also take the shape of a triangle. These numbers also are called triangular numbers. Can you guess the next 3 triangular numbers? Try it. It's very easy. If you subtract the next number from the previous number, then you will get this kind of pattern. As you can see, adding 2 to 1 gives 3. Similarly, adding 3 to 3 gives 6. Adding 4 to 6 gives 10. And adding 5 to 10 gives 15. Following the same pattern, adding 6 to 15 gives the number 21. Similarly, adding 7 to 21 gives 28. And adding 8 to 28 gives 36. Let's consider one more pattern. If we look at any number in the given series 1, 4, 9, 16, etc., it can be represented as squares in an arrangement of dots. Therefore, these numbers are called the square numbers. Can you find any relation among these numbers? Think about it. Here, multiplying 1 multiplied by 1 is 1, 2 multiplied by 2 is 4, 3 multiplied by 3 is 9, and 4 multiplied by 4 is 16. Similarly, the next number 5 multiplied by 5 is 25. Following this pattern, you can find the next square numbers. Sometimes we have to do verbal calculations in our daily life. Understanding the pattern helps us perform them easily. Let's see this pattern. In order to make the calculation of 1423 plus 9 easy, 10 is added to 1423 and 1 is subtracted from the result. Similarly, to simplify 1423 plus 99, 100 is added to 1423 and 1 is subtracted from the result. Similarly, can you solve 1423 plus 999 this way? It can be solved this way. Can you find any pattern for subtraction in 9, 99, 999, etc.? Just think about it. Here, in place of subtracting 9, first we will subtract 10 and then we will add 1. Here, in place of subtracting 99, first we will subtract 100 and then we will add 1. Similarly, in place of subtracting 999, first we will subtract 1000 and then we will add 1. Similarly, we can observe the pattern for multiplication. Pause the video and try to understand this pattern. Here, instead of multiplying 9, 99, 999, we have multiplied 10 minus 1, 100 minus 1 and 1000 minus 1. By using the distributive property over subtraction, we can write it in this way and solve it easily. Today we have learned some interesting patterns in whole numbers. In the next video, we will learn some examples of patterns in whole numbers. Today we will see some examples of patterns in whole numbers. We can store 189 oranges in a box. If we have to transport 120 boxes of oranges in a truck, then how many oranges do we need? In the given example, there are 189 oranges in a box. Then, total oranges in 120 boxes is 120 multiplied by 189. How can we simplify this multiplication? We will express 189 as 200 minus 10 minus 1. By using distributive property of multiplication over subtraction, we can represent it as follows. By solving this, we will get 22,680. Next example, if there are 125 toys in a toy box, then how many toys are there in 64 boxes? Since one box contains 125 toys, the total number of toys in 64 boxes will be 64 multiplied by 125. We can solve this by multiplying both the numbers, but it is time-consuming. Let's learn an interesting way of multiplying numbers by 5, 25, 125. Let's learn how to solve 64 multiplied by 5 first. Since we can write 5 is equal to 10 divided by 2, which can be expressed as 10 by 2. In order to get the product of 64 and 5, we can express it as 64 multiplied by 10 by 2. To solve this, first we have to divide 64 by 2. The outcome is 32. Now, we will multiply 32 by 10 and we get the answer 320. We can solve this easily by verbal calculation. Similarly, in order to solve 64 multiplied by 25, we can replace 25 by 100 by 4 and solve it very easily. By solving this, we get 1600. Now, in the given example, How will you multiply 64 by 125? 125 is equal to 1000 by 8. Therefore, we will replace 125 by 1000 by 8. Then, we will divide 64 by 8. We get 8, which is further multiplied by 1000 to get 8000. Therefore, if there are 125 toys in a box, then there will be 8000 toys in 64 boxes. Here, we can see 3 patterns. In the first pattern, 5, 25, 125, etc., we get the next number by multiplying the number with 5. In the second pattern, 10, 100, 1000, etc., we get the next number by multiplying the number with 10. In the third pattern, 2, 4, 8, etc., we get the next number by multiplying the number with 2. Next example, observe the below pattern and find the next step. Let's understand the first step. Here 5 is expressed as 10 by 2. That is, it is expressed in the form of a fraction whose value is 5. Then 44 is divided by 2 and the quotient is multiplied by 10. We followed a similar pattern for the multiplication of 15 and 25. Therefore, the next step is 44 multiplied by 35, which can be expressed by the fraction 70 by 2. Then, we will divide 44 by 2 and the quotient 22 is multiplied by 70, which can be expressed as 22 multiplied by 70. Here, we observe 2 patterns. Today we have learned some examples of the patterns in whole numbers. Today we will see some common mistakes related to patterns in whole numbers. Common mistake 1. 99 multiplied by 9999 is equal to. To solve this question, we often multiply the given numbers. It can be easily solved with the help of patterns. But it is difficult to multiply 99 and 9999. Sometimes, with the help of patterns, we can represent it as 99 multiplied by 10,000 minus 1. But while solving it, 99 is multiplied by 10,000 and 1 is subtracted from the product. As a result of this mistake, we get 9,89,999, which is an incorrect answer. The correct method is to represent 99 multiplied by 9,999 as 99 multiplied by 10,000 minus 1. It is solved by multiplying 99 with both the numbers in the brackets. By doing so, we get 9,90,000 minus 99 is equal to 9,89,901. Common mistake 2. A library was built in a village. 9 children came to the library on the first day, 11 on the second day, 14 on the third day, and 18 on the fourth day. Following the same pattern, how many children will be there in the library on the seventh day? Sometimes it is difficult to understand if the given numbers are following a pattern. Therefore, students fail to solve the question. Similarly, at times we are in a hurry to understand the pattern. The difference between the first 2 numbers is found and it is considered the same for the rest of the series. Similarly, sometimes the difference between the last 2 numbers is found and it is considered same for the rest of the series. In some cases, the pattern is understood correctly, but difficulty is faced in finding the next term. It is important to understand the pattern to find the next term. Here, the numbers 9, 11, 14, 18 make a pattern. To know the pattern, let's find the relation between the nearest numbers. Here, if we subtract 9 from 11, we get 2. On subtracting 11 from 14, we get 3. Similarly, on subtracting 14 from 18, we get 4. Therefore, in this pattern, 2 is added to 9 to get the next number 11. Then, 3 is added to 11 to get 14, and similarly, 4 is added to 14 to get 18. By following this pattern, add 5 to 18 to get the fifth term, which is 23. Adding 6 to 23, we get the sixth term, which is 29. And adding 7 to 29 to get the seventh term, which is 36. This is the correct answer for the given question. Today we have learned some common mistakes related to patterns in whole numbers.